A researcher wishes to determine whether there is a relationship between the age of a copy machine and the monthly maintenance cost. The data from a sample of 7 copy machines is given below. So like one of the copy machines has an age of 3, it's 3 years old, and a cost of $80. It costs $80 a month for maintenance on that machine. Then one has an age of 5 and a cost of $100, one has an age of 2 and a cost of $75, and so on. So we've got a pair of X and Y values for each of those 7 copy machines. And I've gone ahead and done some calculations on those, including calculating the correlation coefficient R. If you had to calculate this for yourself, you would take these numbers and either plug things into that big ugly formula that we saw for R, or you'd put this data into something like Excel and ask it for the correlation coefficient, or put it into a graphing calculator and have it give you the correlation coefficient, or something like that. But here I've just told you that the correlation coefficient is 0.962. But what I want you to do with that is test the significance of that correlation coefficient at level of significance 0.01. So first of all, what are the null and alternative hypotheses? Well, the null hypothesis is that rho equals 0. Remember that sort of P looking letter is the Greek letter rho. And the alternative hypothesis is that rho does not equal 0. That's what they will always be for this kind of situation where you're testing the significance of the correlation coefficient. You just have to remember rho is 0 is the null hypothesis, and rho is not equal to 0 is the alternative hypothesis. Next, we need to look up on table I the value for, well, the value that it gives you to compare that R to. Now remember, table I looks something like this, and I will give you this table on the final exam. It's in the back of your book, but you may not still have your book, so I'll give you the table to refer to. And it does explain how to use it. You're going to be rejecting the null hypothesis, rho equals 0, if the absolute value of R, so if R is negative, you're just looking at the absolute value of R, which is positive, and you're comparing it to the value in the table. So in this problem, alpha, the level of significance, was 0.01. So we're looking in this column. And N was 7, because we had 7 data points. And so degrees of freedom is going to be 5. And so the number in the table is 0.875 here. So the absolute value of R, 0.962, is greater than the number on table I, 0.875. Therefore, we do just what it says here. We reject the null hypothesis. And when we do reject the null hypothesis, that means there is enough evidence to conclude something. In this case, to say that there is a significant positive relationship between age and cost. How do we know it's positive? Well, because R is a positive number. And that turned out to happen because in our data points, the bigger X's went with the bigger Y's and the smaller X's went with the smaller Y's. But in general, R is positive when you have a positive relationship, negative when you have a negative relationship. Now for part B, now I might just give you the regression line equation, or I might ask you to find it yourself. If I ask you to find it yourself, you'll be using those formulas. So the formulas for calculating the A and the B Here they are. Whoops. So here are the formulas, and here's what they look like if you plug in the actual numbers. And these numbers come from that table that I gave you earlier. So like the sum of the y's was 572. That's what all the y values added up to. And the sum of x squared was 68. And the n in the formula is 7. So A comes out to be 55.47 and B comes out to be 9.18. So the equation is y prime equals A plus bx. Y prime equals 55.47 plus 9.18x. Now I will almost certainly, whether I ask you to find that equation or not, I'll ask you to use it in a question like this one. Use it to predict the monthly maintenance cost of a copy machine whose age is 6 years. So we're taking that 6 and we're putting it in for x, because x stands for the number of years. And that means we're calculating 55.47 plus 9.18 times 6. And that comes out to be 110.55.